Let's take a look at a Panasonic Nanoe, and this is a air purifier for vehicles. It's the model number F-GCM01D, and the whole reason I bought it is because I wanted to see the Panasonic technology, because this is their alternative to Sharp's plasma cluster type stuff. So I have a 12-volt supply here, and I'll give you the current ratings of this, and we can try it out. Let's make sure I get the connections right so I don't just blow it up straight off the bat. So the power's on, no lights on. There's a little vent that you can toggle up to different settings. If I press, at the moment it's drawing 2 milliamps. If I press the button, the fan starts running at a low level. I can feel the air being pulled in from the side here and blown out here. And it says 120 milliamps. Next setting, high setting, is 176 milliamps. Okay. Any other things here? Is there any noise? Oh, I can hear a slight hissing noise. Can you hear this? Don't know. Probably you just got huge quantities of air blowing across the microphone there. I shall turn the power supply off, and we shall explore this thing. So let's undo this first. It has a captive plug. That's quite good. Well, captive, I say captive, you can change it. What looks like the little fan in there. And there's a screw there. This is good. What is this going to give us access to? Let's just take all the screws out. Screw. And I wonder if there's any screws hiding under these. We can pop the feet off and see if there are screws under there. But let's take this screw off and just see if it gives better access. So what this does is it's one of these things that produces an electrostatic discharge inside. Ooh, this is promising. There's a little catch. Let's push the little catch in. Is this how you're supposed to do it? Dunno. Ooh. That doesn't feel great. That's better. Ooh. So there's the electronics. Processor. This might be a memory chip. Could be a memory chip for storing if the unit has expired and needs replaced, or just storing settings. Let's pull this out. Not a lot on the top. You've got a button, a resonator for the processor, a little electrolytic, and 3 LEDs. Does this connector come off? No, this is not one of these removable connectors. This is one of these ones that it's just a solderable header, isn't it? Can we get any more from here, or do I have to go in from another access? Let's pop these feet off at the bottom and see if it gives any better access. Are there going to be hidden screws? No. I think these are just... I don't think these are supposed to come out of here. Uh-oh. Radio, that's okay. And no, that'll be a triple no then. Oh, this looks as though... Oh, that's better. Ooh, there's the high voltage transform look of it. Or is that filtering? I think that's a high voltage. And there's a screening around this. Probably for RF screening, or is it a ground plane for the unit? Oh, this looks more promising. Oh, this looks as though it might come off. No, nothing. Oops, don't know if that was supposed to happen. But not to worry, it's happened. Oh, I might have to undo some of these connectors. These ones are unpluggable. Ooh, there's the high... Oh, is that the high voltage module? Is it the high voltage module? Maybe this was just a COM mode suppression choke. It looks like it might be. Let's pull this connector off. This isn't necessarily going back together, because really I got this so we could take it apart. And what about this? Oh, this is the little clip for the cabling. Jolly good. Let's just whip all the connectors off then and slide it out. How very modular. Yeah, this looks like it's just power filtering. This is the juicy bit down here by the look of it. Any more screws to take out? No, there's a clip though. And side clips. Oh, there we go. What is that? Is that important? I don't know. It's a little rubber thing. And there's a little chip in the back of this. Interesting. So let's unplug this as well then. Let's try and unplug this. Is that captive? It might be captive. Oh, it is. You just push it in and unclip it. And then is this little spade connector. Yes, it is, but it's not coming off. Let's grip it tenderly with a pair of side cutters and just whip it off. No, let's not then. It's pushed on and latched on. Okay, that's all right. So let's see where we're going here. Let's cut this cable tie, making sure I don't cut the wires. Not that it really matters. It isn't going back together. This bit can come out the way. This is total destruction, isn't it? This is for all the people who have one of these and want to know what's inside it. Right, now we're getting into the juicy bit here. This is where all the magic's happening. Bit of foam, bit of filtering material there. Here is the motor. The motor comes off like that. So where was that blowing the air? It was just blowing it straight up through the top. Ooh, but there's a, possibly it's creating an upward draft, like the Venturi effect, that is pulling air through here. So this is where the electronics are going to be, isn't it? This is where the high voltage stuff maybe. I say that, it might not be. Is this riveted? Hold on, let's get the spudger into it. Spudger. No, I don't think it's riveted. How is this going to come off then? Right. I think this is a little Nanoe unit. It is the Nanoe unit. What do we have? We have a metal ring and a spike behind it. So this is kind of the high voltage here. That's odd. And this white one, oh, and the black one, what is that about? Are these both connected together? Or are they separate? Hold on, let's meter that. So are these connected together? They are connected together. I wonder why that is. Unless one of them was this coming from the high voltage board and the other was the reference to the rest of the circuitry, or maybe it's some sort of sensing system. Don't know. Or maybe it just works on a elapsed time of the lifespan of the unit. But we can take a closer look at this. They have kind of spot welded, well, they've hot staked this into position. So that means that all the secret sauce is in here, and you know what? It's not going to be a integrated module as such, right? Tell you what, I shall take a look at this. I'm not going to reverse engineer it completely, because that would be a lot of work to reverse engineer this. There's a lot of components in this. But I can take a look and see if I can work out if this is just a simple module just getting power, or if it's actually got something else to it. But there are 4 connections suggesting maybe a feedback winding and the sort of power winding for a primary. Right, tell you what, I shall explore this. One moment, please. Well, that was not easy. Not at all. I have depotted the module, but it was very difficult for a very odd reason. Let me show you the circuit board inside the module. The circuit board inside the module looks like this. It's basically copper tracks with the solder connections, but no actual circuit board that I could see. The resin just seemed to come away from around it, unless the circuit board itself was made of the same resin, so the whole lot could be potted completely. But very, very difficult to actually depot in a controlled manner. But there were some interesting components, not that many components in it, which doesn't tally up the rest of the circuit board, which is smothered in components. This is a common mode suppression choke. So this is the main incoming supply and filtering board. Then we got the main processor card that controls everything with the indicator LEDs and the button for selecting modes. And we have the high voltage board, which has multiple chips on either side. It's quite a complex thing. And the big potted module. The potted module contained a transformer, as you'd expect, with an external core, very odd construction, and the multi-layer windings. I'll just zoom down this a bit because we need to get closer. But the multi-segmented windings for the high voltage, and the typical very low impedance, small number of turns, high voltage primary, should I say high current primary, and then the high voltage secondary. What is the next thing that's worth actually looking at here? Let's get this out of the way. Look at the amount of screening that was in it. That was all wrapped around with screening. Very, very interesting. So the actual unit itself, here's the fan that's drawing in air in the side here, and it's blowing it out this spout here. But I thought it'd be blowing it past the corona discharge device, because that's ultimately what it is, but it's not. It's got a port here, and it is a Venturi effect. It's got this little tunnel here that creates a slight vacuum as the air blows out, and that vacuum draws air through this carbon filter here. This carbon filter, a little bag of carbon granules by the look of it. And then that ducts down to this port here, and with a power connector here, has another little packet of carbon granules, and then that leads across to, let me see here, to the output port of this, where the corona discharge is occurring, inside here. And the air intake for that, let me try and remember this, is coming from, it's coming from this side via this port just at one corner of the fan. It's very black as well, that's not helping. So the air is effectively being pulled through the carbon by the granules, drawn through here, the air intake is here, and then the actual unit itself, let's see if we can get this back off now. Have I latched this on again? Probably. Oh, I have latched it on, haven't I? Stand by for loud crunching, popping, clacking noises. There we go. And here's the very odd module. Now, it's odd because there is this sort of needlepoint emitter, except it's not a needle at all. It's a little rounded head. And then there's the ring in front of it. But the needle itself has two connections that are basically shorted together. I get the feeling that that may be a safety feature if it starts getting too hot, and it may trip something that breaks the circuit. Not sure, but quite odd that this is the high voltage positive versus the negative is actually the needle itself is effectively referenced to the 0 volt reference rail in the circuitry. Let me show you things. Let me show you this. Once I depotted the module, there was one capacitor and one diode in it, other than the transformer, to create the high voltage supply. A very high voltage 150 picofarad capacitor, if I'm correct. I think it was yes, it was on about 150 picofarad. And then this long resistor, which was very, very difficult to depot. It's a high value resistor with 3 taps along it. It's like a custom resistor array. And that is not just used to limit the current to the needlepoint emitter, or the case, as the case is in this case. But it also acts as a divider that also provides a high voltage tap off via another high voltage resistor section to the circuitry. Let me show you the circuit boards. So we have this area here is where the high voltage module was. And the main thing of note is that we've got the positive connected to one end of the low number turns primary, and then it also at the other end, it is pulled down via this MOSFET to the negative rail. So by pulsing it, that MOSFET on and off, it basically creates a pulsing magnetic field in this primary. That creates a high voltage in the secondary. But one side is referenced to the high voltage winding, but the other one, you can see this little track around here. I should focus down this. See a little track round here? That is the high voltage feedback, and they've really gone to town to avoid that causing any issues with tracking. And even this side, they've got the little track surrounding it. And then feeding back to a potential divider over here that then signals back to the control chip. It's quite complex. There is also another, what looks like a power supply. And also, they've got 7 linkable options here. Not sure what that's about, with a little resistor in one of them. Maybe a universal design. Maybe this control circuit board is designed for multiple units. I should zoom out a bit, shouldn't I? So you can see that. But the next bit is just to show you the schematic. And it's not, I'm not going to reverse engineer the whole thing by a long chalk, because that would be arduous. But here's the primary of the high voltage transformer being pulsed by that MOSFET. There's the secondary reference to one end of that, which ends up finding its way back to the negative connection. And that goes through this diode, high voltage diode. I had to actually, in circuit, I had to find the polarity before damaging it. I had to apply a fairly high voltage across it with a current limiting resistor and just turn the voltage up until the current started flowing through that. Because these high voltage diodes, these ones, where is it? Here, very small, but they actually contain a stack of diodes inside, which means they've got a very high forward voltage. And that's how they get the high voltage rating. But that charges this capacitor here. There's that odd, this is all just one big resistor. Very hard to get out. I got some information off it, but not really that much. I think it's a proprietary component, but it's inside, it's a ceramic layer with the carbon film on it, and then it's dipped in this resin, and then it was potted in. So this is one tap coming off to limit the current to the ring that's this bit here, and I'll draw that in a moment. And the other, the negative, the little electrode at the back is just referenced to the 0 volt rail. And there's that other resistor going to the sense circuitry, where it will effectively be going to a resistor and then a capacitor probably across that. And then the actual sensing circuitry to actually monitor the high voltage there. Quite an unusual design. Let me draw the electrode arrangement here, because it's very odd. Now, normally with these sort of things, you have a high spike at a high negative voltage, and then you've got the ring reference to the other leg of the supply, and then you end up the corona discharge there. But they've kind of done that, but in the reverse. The ring is the high voltage positive, and this is on the 0 volt rail. So if we take a look at it, if we took a slice on the side, it looks like this. Here's the metal plate, and then it dips down and then comes up, and they've punched a hole through here. So it's imagine this, if you saw this on the side, it would be basically a ring with a hole in it, but it's scooped down in there. And that is in front of a little, I can't really call it a needle because it's got a curved end. And that is basically, this is high voltage positive, this is 0 volts, and it creates a very fierce corona there that fuzzes out, and I can show you that. I took a picture of it. It was bright enough to actually take a picture. The metal ring is in the front here. There's the little electrode tip, and you can see it's got quite a hot spot. I'll zoom down this. And then this corona just sort of created around that. It's very odd. I wonder what the reasoning is behind this. I wonder if there's something special about this little, what I'm calling a needle, but it's not really a needle. Very strange thing. Very Japanese, I say. Their designs tend to be quite complex. Is this their way of getting around patents by other manufacturers? Although, to be honest, if you look back, all these owe their existence to the Chizhevsky, Alexander Chizhevsky, the original Russian ionization chandelier. They're basically just ionisers, but with a sort of like a plate in front of them. Or it could be that Cecil Copy Laws, who commercialised the first ioniser for home use, and it does have the metal ring in front of the needle, so that's one of the first ionisers. So I don't know if Sharp or Panasonic can really make any great claims to pioneering technology. But the reason I think they've got the carbon granules is because the air is pulled through this, And there will be ozone produced. The carbon granules might be to reduce the ozone, but leave the other active components. I'm not sure. Very hard to say. But they've gone to town with what I believe to be carbon granules here. Kind of like want to open this up. I know they'll just go everywhere. It does look like just basically activated carbon granules. The dust is going everywhere. But that is it. The Sharp plasma cluster is very different. It has a positive and negative charged needle cluster. Depending on the technology, it's one polarity ring. Was it two needles? One was positive, one was negative in front of a common ring plate. But the more recent one is just at the two carbon fiber brushes, I'm pretty sure. But this one has that completely different approach of having the ring at the positive and high voltage positive and this at the 0 volts, pulling basically a discharge from it. Very odd. It's very hard to say what's going on in the plasma because it is like amazing rocket science, air chemistry that's going on. It's emulating nature and that's ultimately what they're aiming at. I'm guessing this is just to remove the ozone aspect just because, well, people are very pernickety about that. But there we have it. The Panasonic, what is it? What is that? The Nano. Nano with an E. I'll just write that down. Nano. Basically speaking, a corona discharge air purifier that just emulates nature and creating that electrostatic effect that breaks apart air molecules into components, bits, and then they reform temporarily in unstable forms, and that's what has the cleaning effect. Very interesting, but very time consuming to take apart, and an extremely complex unit, just like Japanese technology normally is.